Hello students, and we are going to today work on our science gizmos for our inclined plane. We're going to start our work today with our simple machines, building up to our final one, the trebuchet, which is going to be a lot of fun. To understand how this final one works, so you need to look at the various different parts of simple machines to understand how all these components can come together to create something like a trebuchet or a catapult. So let's look at our inclined plane here. Okay. So it says drag ants to the bottom of the stick to push up the blueberry. So I have one ant, and this is just the basic 20 centimeters here, and 10 centimeters tall. So this is the length of it and the height of it. It almost forms a triangle here. And let's see what happens with our ant. Okay, so you can see over the course of time that our ant at this angle is unable to move the blueberry up the hill. So perhaps if I were to increase the number of ants, let's say 3 ants, let's see what happens. Great. So 3 ants are capable with more force to move that blueberry up, but the 1 was not. I'm willing to bet that if we were to add all of our ants here, this time would be even faster because there's more force pushing it up. Now let's try our angle here. So let's see if we make it even longer, 30 centimeters. Notice this incline is a little easier to walk up. Let's see if 1 ant is capable of this. Nope, still incapable. But perhaps 2 ants this time. Excellent. So you'll notice that by increasing the length of this and making this slope a little easier to walk up, you're able to use just 1 less ant to push this blueberry. And while it may have taken more time, it was probably a lot less effort since it only took 2 ants to move it. This is the case for inclined planes. If I were to, let's say, make it 15 centimeters, this very, very steep angle, we'll see if 3 ants was able to move this. Okay. So you notice that if I change this angle to be even more steep, the 3 ants isn't enough. They don't have enough force. They don't have enough strength to move it up this very steep incline. Let's see how many ants it takes to move this blueberry up this steep incline. Perhaps 4. Great. Although it was kind of slow, they were able with 4 ants to move it up this steep slope. So a very simple correlation you can make here is that the steeper the slope here, the more effort, the more force, the more ants you'll have to use to push it up. And the more ants you use, perhaps also the faster it will go. So what I want you guys to do is to play around with this and see the different things you can move up it, the number of ants, and the different lengths you can use to create slopes. You also have this tab here with friction and no friction. So of course, no friction being that there isn't any resistance on the stick itself. In the real world, we have things like friction. For instance, if you rub your hands together very fast, it's that heat you feel. It's when things rub up against each other. If you push your hands hard, very, very hard together, you'll notice it's harder to rub your hands together because you're increasing the amount of friction. So play with that as well to see how that will change the way you can move things up and down and the size of the objects and how many ants you'll need. There's a lot of variables here to play around with. When you're done experimenting with this and getting for a feel how this gizmo works, as usual, come down here and see if you can answer these questions as best as you can. Some of them, for instance, number 5 here, will require you to go back and to set it up in a way to almost create a hypothesis and an experiment in this. I look forward to seeing your work, and I'll talk to you guys tomorrow.